All right, you guys ready? Exponential function. Parent function for exponential functions, y equals a times b to the x minus h plus k, right? Where h and k are 0. That's the parent function. Now, if my b is greater than 1, I have growth. If my b is a fraction between 0 and 1, I have decay. So just by looking at this equation, what do I have? Growth or decay? What's my b? 1/3. So it's a fraction between 0 and 1, so I have decay. All right. What's my horizontal? Remember, exponential functions, whether it's growth or decay, has horizontal asymptotes. The log functions have vertical asymptotes. Now, horizontal asymptotes are determined by our k's. Vertical asymptotes are determined by our h's. Okay. So this is an exponential function. The horizontal asymptote is going to be determined by our k. So I have a minus 4. Horizontal, it's a y equation, minus 4. So at minus 4, y equals minus 4 is going to be my horizontal asymptote. And if you don't believe me, you can always just put it in your calculators, right? 1/3 raised to the, now please use parentheses for especially in your exponents, x plus 5. Now on your calculators, you're going to have to use that right arrow key to get out of that exponent, right? Your calculators are a little different than mine. And then I'm going to put a minus 4, graph it, and sure enough, my horizontal asymptote there is negative 4. Okay. Might as well, since we're on the calculator, let's go ahead and get some points and graph this. So I'm going to go to my second graph to get my table. I did something wrong. Oh, no, I didn't. I'm all the way at x equal. I'm going to start back at 0. Back to my table. Okay, I'm going to get some points here and use some whole numbers. Negative 7, 5. So negative 7, 5. Negative 6, negative 1. Negative 5, negative 3. And then it starts getting closer and closer to that y equal negative 4. This is a decay function. Now, okay, so there's the graph. My domain for exponential function is always going to be negative infinity, positive infinity. Now for the log function, which undoes exponential forms, right? They undo each other. It's just everything's going to be the opposite. So for the log functions, the range is always going to be negative infinity to positive infinity for this class. Now my range is going to be my y values. It's going to be my k, which which is -4. Okay, it's the horizontal asymptote. And in this case, it's going to positive infinity. And then my end behavior, as x goes to negative infinity, so I start at the origin, as x goes to the left, negative infinity, my y goes to positive infinity. And start at the origin, as my x goes to positive infinity or to the right, my y tries to get to that -4. Okay, number 2 says, I'm looking at the function, the f of x equals 3 times 4 to the negative x. Well, here my b is 4. Don't make the mistake, what is the base? It's 4. Don't make the mistake saying, hey, it's bigger than 1, so it's got to be growth. There's a negative exponent here, right? Negative exponent, that's going to make the base not 4. It's going to make it 1/4. So this is actually a decay problem because of that negative exponent. So be careful. Take your time on the quiz. Our transformations are h and k's. Here's my h. And here's my k. So in this particular problem, I'm going to go, remember our h is opposite the sign, so I'm going to go to the right 7 and up 2. Number 4. All right. Huh? Which one? You good? All right. Number 4. They actually give you the formula to use. Okay? So we're going to have to figure out our A, our Y if we have to, and our R and our T. So let's start reading this. A scientist estimates that a specimen begins with 800 bacteria. Now, begins with 800, that's our initial amount. What variable is that going to be? That's our A, that's our capital A, that's our initial amount. Now, I know in the following formulas, they're going to change variables on you. Okay, watch where that is. It's before the parentheses. That's the initial amount. If the specimen grows, so it's going to be a plus sign, by 12.5%, well, there's our rate. Move the decimal place over twice, 0.125. There's our rate. Write an equation that represents bacteria's growth. So step 1, let's just stop there. Okay. Write an equation. That's the model. When it says write an equation, that means they want the model. So I have y equals, we have our A, which is 800, parentheses, 1, it's growth, so I'm going to use a plus sign. Our R, 0.125, raised to the, well, it's a model, it's an equation, so I have to have my variable, t. I'm going to leave the t in there. So there's my model. Remember, the model's got to have that variable. When will then calculate, so I'm done with that part. It says then calculate how many minutes will pass before the population reaches 12,000. Now, what's that 12,000? Is it the Y or the T? Well, it's the Y. Okay, that's the initial amount going to 12,000. So, with a variable in our, not the Y side of the equation, when we have a variable, are we going to graph it or are we going to just compute it? Okay, I'll help you out. When we have a variable, we're not going to have to graph it. When it's a model, you graph. So I'm going to put this in the Y equals button. 800, 1 plus 0.125 raised to the, now I'm not going to use T, I'm going to use X. Graph it. Wrong button. Graph it. And tell you the truth, I really don't care what the graph looks like because I'm looking for that Y equals 12,000. So I'm going to go to my table. And I need my Y, I need it to be 12,000. So I'm just going to scroll until I get to 12,000. Oh, here, oh no, that's 1,200. So I'm going to keep going. I need 12,000. Oh, there it is. 12,012. So between the years 22 and 23. So between 22 and 23. Questions? Okay, number 5. This time it says, suppose you invest 1245. Again, that's our initial amount, right? And in this case, they did switch up the variables in our formula, okay? The initial amount, which is the number before the parentheses, that's our capital P. And they actually put the capital A for Y. So why they do that, I don't know. You're going to have to be careful. Okay, 1245 in an account paying 4.5% interest. So there's my rate. I need to move the decimal place over 2 places, so I'm going to need to put a 0 there. 0.045. Compounded monthly. Now, we have that word compounded. That's our end. And how many months in a year? Well, there's 12. Step 1, write the model for the investment. So again, the model is going to have a variable. Let's see. I've got my P, which is 1245, times 1. It's paying me, so it's a growth. My rate, which is 0.045, divided by n, which is 12, raised. Put your parentheses in the exponents especially, otherwise you get the wrong answer. My n is 12, and at this point in the problem, I don't have a value for t. So it's to the 12t. And again, it's a model, so I expected to have a variable there. All right, then it says, find the account balance after 13 years. Well, they actually give us our t. Okay? They give us our t. So when they give us the t, I'm going to substitute it in, 13. I no longer have a variable there, not a model anymore. So since I don't have a variable there, I have 12 times 13, I'm just going to compute this. So I don't need the y equals button and graph it, I just need to compute it. So I have 1245 times 1 plus 0.045 divided by 12 raised to the, and again, you need parentheses. If you don't have parentheses in your exponent, you're going to get the wrong answer. 12 times 13. And just hit enter. And that's the amount after 13 years. 2232.32. Now, before you go on to the next question, look at it. Does it make sense? I start with $1,250 and I end up with $2,200 after 13 years. Does it make sense? Yeah. I mean, if you get an answer like $800 or $5 million, you did something wrong. You probably didn't put parentheses in that. So, look at it for just a couple of seconds before you go on. Does it make sense? All right, and then we looked at continuously compounded, right? Continuously compounded. When you see that word continuously, you have to use the natural E, right? Okay, they even give you the formula here in the problem. All right, let's read it. You invest your birthday money in an account that collects 2%. Well, there's our rate. Move it over 2 places, you're going to need a 0.02. How long will it take for the account balance to triple? Now, what's our P? What's our P in the problem? How much birthday money did they give us? We don't know, do we? So we get to choose our P. I'm going to choose $1. Okay? That means they're looking for $3. That's our Y. Or our, I think they use capital A, right? Capital A. So our model. Remember, model's got to have a variable. So A equals P, or P, $1, right? So that's $1. E to the R, just 0.02. And our T, we're going to leave T in there because I need a variable. Remember, E is a number. Okay. When will the balance triple? So, am I going to put this in my Y equals button and graph it, or am I just going to compute it? It's a model. It has a variable, so I need to put it in my Y equals. I have 1, and my E button, remember, it's second ln key. E to the 0.02, and I'm going to use X, close parenthesis. I'm going to graph it. Really care about what the graph looks like. I need to find when Y or A, capital A, equals 3. I'm going to go to my table, second graph, and I'm just going to press and hold until I get to Y equal 3. Oh, there it is. So between 54 and 55. Okay, between 54 and 55. Now, number 7, we really didn't do this when we were doing applications. It's an awful lot of work for very minimal concept. I'll make it extra credit. Okay. All right. So let's look at number 8. It says rewrite the following into either log or exponential form. So remember I told you guys kind of write this down on a card or something. I told my first hour I'd actually make up a card. So I have log form and I have exponential form. And let's see, log form, I have to have the word log, of course. Then I have a base B. And then I have the number y. That's going to equal the exponent. And we'll use x. It's our exponent. Okay. Exponential form, well, that's where I have my base. And this is probably what you guys are using. Base to the exponent equals the number. And they go back and forth, and one undoes the other. So there's inverse property. All right, rewrite the following in either log or exponential form. We're in log form because there's log. Now, do yourselves a favor. Just put a note what's what in here. Okay? Log base, now that's the base, 8. 64 is our y, and x is our exponent. Okay? So when I go to put it in exponential form, well, I need my base, which is 8. I need my exponent, which is x, equals my y, which is 64. Makes your lives a lot easier. Take that extra step. Label things. Base, exponent, and y. Y happens to be y here. So there's no log, so they want it in log form. Log to the base, which is 3, to the y, which is y. That was nice. Equals my exponent, which is 6. Okay? Make your lives easier. Label them before you put them into the form. All right, 10 through 12. Evaluate. Well, we're missing something. Right? Notice we're missing the x, the equals x. Well, let's go ahead and put them in. Okay. And I'm going to put this in exponential form because it makes my life easier. Base 5, exponent x equals y, 125. Now, if you don't have your handy-dandy little yellow charts, you can always put this in a calculator. Remember, this is a power, so it's being multiplied by itself. So all I have to do is, well, I'm going to take 5 times 5, just keep multiplying it by itself until I get 125 times 5, and there it is. Well, how many 5s do I have? 2, 3. So x has to equal. But there's an exponential form. Exponential form by basis 4 to the exponent x, that equals my y, which is 1. What does x have to be? What makes any number in exponential form the number 1? Has to be 0. Anything raised to the 0 is 1. Okay, let's do it again here. Base 2 to the x equals my y is 1/8. Now, I'm going from a whole number to a fraction. So the sign of my exponent has to be negative. Okay? Whether I'm going from a whole number to a fraction or fraction to a whole number, I'm going to have to flip it. Then I need to know how many 2's I multiply it by itself to get 8. 2 times 2, 4 times 2 is 8, so it has to be 3. X equals negative 3. 13 through 15, you're just applying an inverse property to these. Okay? Remember, logs cancel out the bases of exponents, and the bases of exponents cancel out logs. That's all they want you to do here. Notice that I have a log x and a base x. They cancel each other out. So I'm left with y. Base m cancels out log base m, and I'm left with x. Don't make this harder than it really is. Now, here I have log base 4, but the base is 64. I can still cancel out because 64 is a perfect cube of 4. So I can actually rewrite this as log 4 of 4 cubed. Don't forget your x. Now I can cancel out the 4's log and with the log base 4, and I'm left with 3x. Okay, 16, you actually have to find the inverse. Step 1, switch y and x. So I get x equals log 5 of y. Now I have to get y by itself. How do I get rid of the log base 5? Well, I need that exponent, the base 5, and use that log base 5 as an exponent. They cancel out. I get my y. Don't forget, whatever I do to one side, I have to do to the other. So I get 5 to the x equals my y, and that's the end. Questions? And you are actively engaged. I am so happy about that. I really am. I'll think. All right. Graphing, when we did the exponential functions, now we're going to do the log function, right? Okay. Remember, this is my h, that's my k. So what are my shifts here? My transformations? Left 5, right? Because it's the opposite of the sign. It's in the mathematical symbol parentheses. So it's opposite the sign. Left 5, up 3. Now, for log functions, now you can do this on your calculators and have at it. I think it's easier to do without the calculator. Okay. Remember the parent function y equals log of x, and then there's a minus h and a plus k. The h is your now exponential functions have horizontal asymptotes. Log functions are going to have vertical asymptotes. Remember, they undo each other, so they're different. My h is opposite the sign here, so it's -5. So my asymptote, vertical asymptote at -5, x equals -5. You are paying attention. Domain and range switch, right? The domains were always negative infinity, positive infinity for exponential functions. So it's going to be the range that's negative infinity, positive infinity. Our domain is going to be our h comma infinity. You know what? I'm going to go ahead and graph it first. Okay. So the parent function has an x-intercept of 1 comma 0. I'm going to go to the left 5 and up 3. 1, 2, 3, 4, 5. 1, 2, 3. Goes off this way. And then it comes down, hugs it, tries to cross it, but doesn't. There's my log function. Just think it's easier to do. Okay, domain. Well, there's that x equals -5, or h, and it's going to go off to positive. Now, if you do it on the calculator, this is why I don't like calculators for log functions. If you put it in the calculator, log x plus 5 plus 3, when you graph it, it doesn't give you the whole function because that whole pixel problem I told you. Any questions on this? And I have no idea what time it is. 10:06.